My name is Nathan Tabor. I'm a senior product manager here on the Amazon EKS team, Amazon Elastic Kubernetes Service team. And I'm joined by my colleague Massimo. Massimo works on our team as a principal advocate. Awesome, welcome. So today we're going to be taking a first look at how you can use Amazon Elastic Container Service with AWS Fargate to run your Kubernetes applications. So let's take a look at this. So I wanted to start a little bit with what are we doing at AWS around Kubernetes? What are we doing around Amazon EKS? Why did we build this thing? Why does it matter? Why would we build something like AWS Fargate? How does this all kind of work together? We're going to start with a little bit of an overview and why we built this, how we built it. Massimo is going to dive deep into what it means to start using this. By the time you're done here, you should have a really clear picture of why did we build Fargate? How does Fargate work with Kubernetes? How can you actually get started using this right now? This is generally available, so we're super, super excited to be bringing this to you guys. It's been a huge effort from our team, and so this is one of the most exciting things for me in Las Vegas right now. There's nothing out on the strip that's more exciting that I'd rather be doing, so I'm really excited to be here with all of you guys. Awesome. So let me talk a little bit about what does it mean to run Kubernetes on AWS? What's the mission of my team? So I personally work on Amazon EKS, but my larger team, my team is working on Kubernetes on AWS. The general manager, the person at Amazon who's actually responsible for all of this stuff from a management perspective, his title is actually General Manager of Kubernetes on AWS, not EKS. So our mission on this team is to make AWS the best place for you to run your Kubernetes applications. And our goal is to remove the undifferentiated heavy lifting, all that extra work, the stuff that you really, why do you choose a managed cloud provider? You can start up 100 Raspberry Pis in your office and you can do all of this. Really, I'm serious, you can. But why would you choose the cloud? Why are we here at reInvent? And the goal is that we're going to remove all that extra work, that heavy lifting that you need to do to get your ideas off the ground, to get your applications into production, and making it easier for you to not just run things, but also to optimize things that you've already built. Applications that are anywhere from, hey, we built those a year ago and they're running directly on virtual machines. We want to make them a little bit easier to build and manage with Kubernetes, to, wow, this COBOL code was written 25 years ago. I was maybe not even in college at that point. My dad was a COBOL programmer, so, it goes like that. And he might have written this code. Who knows? And we have to find a way to make that more efficient. We can't lose the business logic. We have to run that at scale. We have to continue to optimize the tooling and the processes and the resource utilization around all those things. So this is our mission at AWS. This is our mission on the Kubernetes team. This is our mission with Amazon EKS. And EKS is one way that we make Kubernetes really awesome on AWS. So there's a few guiding principles for how we build EKS and the things that matter for us when we have this managed Kubernetes experience on the AWS cloud. So the first thing that's important is that we build to support production workloads for day one for any size of customer. So whether you're a startup or you're running large enterprise workloads supporting teams of hundreds or maybe thousands of developers, you should be able to start an Amazon EKS cluster and have it just work. This is super important for us. We actually offer a service level agreement. It's a legally binding agreement that we will have 99.9% uptime availability on that Kubernetes cluster endpoint. And we've learned a lot at AWS for how we run production services at cloud scale. And I know this morning Werner Vogels was talking a little bit about this. What do we do on Amazon.com? How do we actually optimize for things at the scale? And our team is full of people not just Kubernetes experts, but also longtime Amazonians and longtime people that have worked at AWS. And we built Amazon EKS to take advantage of all the learnings that we've had at Amazon and at AWS about running services in the cloud at scale for customers. Second, what's really important for us with EKS is that native tooling and upstream APIs, they just work seamlessly with EKS. And the reason for that is because we're committed to running upstream Kubernetes. So our customers tell us this is critical to making EKS useful. There's no point in having a Kubernetes service if you can't use Kubernetes things, the Kubernetes ecosystem, the Kubernetes extensibility model, the ability to write custom controllers, all that goodness that comes around with this declarative API model that Kubernetes offers. We want that to just be able to come to EKS and to work. And so we run upstream conformant vanilla Kubernetes on EKS clusters. And we believe that this is probably one of the things that really makes this compelling. If we didn't do this, there'd be actually no point to even having the service. And then second, being upstream means being good community citizens. It means doing things that actually make Kubernetes better overall on AWS, but also anywhere that our customers choose to run it. And this is another really good reason why people are using EKS today on AWS. It's because they can have Kubernetes in their data center, they can have Kubernetes in the cloud, they can have applications that are running in both places, and when their teams need to move applications or run them in different places, they don't have to relearn tons of things. They don't have to use totally different tooling. They can have the same processes, the same monitoring, the same logging, the same basic stuff. There are some differences in Kubernetes with where you run it, but in general, the APIs are the same, the way it behaves is the same, and so this is important for us to making Kubernetes really good to run anywhere. So our team spent a lot of time contributing bug fixes, security patching, tooling improvements to the community. We're constantly listening to customers. We're refining open source projects that improve the experience of Kubernetes. And we are AWS after all. So it's super important that along with the flexibility of the API, you get the power of the AWS infrastructure. So this means integrations from things like storage, monitoring, logging, networking, auditing, databases, traffic routing, ingress, all sorts of stuff. Probably the most important thing that we've been working on, which is maybe not the most important, but a very important thing, is compute. It's having everything together. Our goal is that you can have all the building blocks for Kubernetes, all the building blocks that you need to run your application in a single place. And you should be able to create a cluster and have that cluster ready to go. We want to give you all the things that you need to run that cluster, the compute resources, the tools, and the controls that you need to run your applications, and give you those in the form of smart building blocks, smart automation that lets you take advantage of the pieces of the cloud, the pieces of the building blocks that you need to build and run your applications, and actually not use the ones that you don't want to use. If you don't want to use something, you don't have to use it. If you want it, it should be there at your fingertips. And we're always going to bias towards giving you this flexibility and this control on your clusters while making it easy to run mission-critical applications in the cloud. So obviously, that's a big vision. It doesn't happen overnight. And we've actually been at this for years. So I'm going to talk a little bit about where did we start and why did we get here? Why did we build all this stuff, right? So several years ago, we saw people running stuff with Docker directly on EC2. And they were running them directly on EC2, and our customers were doing this on their own. They were doing it in their own accounts. You may have been one of those people, or you may still be, possibly. And that was everything above the line here, right? And our customers told us that this was great. We love EC2. We love the reliable compute infrastructure. We like the networking. We like the storage options. It's super good, but it's actually a heck of a lot of work to run containers directly on EC2 and manage everything yourself. And so we wanted to make this easier. And in 2015, we launched Amazon ECS. ECS is our native AWS container orchestration service. Lets you launch containers onto a cluster, helps manage the lifecycle of those containers. ECS is managed by AWS, so it takes away a lot of the heavy lifting from running containers out of your hands. So because we manage ECS, it's below the line here, right? So above the line is managed by a customer, and below the line is managed by AWS. So in 2017, we added Fargate support to ECS. We're going to talk a lot about Fargate, but this is when we first announced Fargate at reInvent 2 years ago. And similar to how we noticed customers running Docker directly on EC2, we started to see probably around 2016, so Kubernetes became generally available, Kubernetes 1.0, and customers started adopting Kubernetes because of the extensibility of the API model, because of the portability of the APIs. And we started to see customers running Kubernetes on EC2 virtual machines. And these customers, many of you, they told us that they wanted an easier way to run Kubernetes on AWS. So also in 2017, we announced, and then in 2018, we made this generally available, Amazon Elastic Kubernetes Service. This is a managed Kubernetes control plane for clusters on AWS. So service is about 1.5 years old now, and this has been phase 1 of EKS, managing the control plane. So Kubernetes makes it easy to package and run your applications and manage a cluster of compute to run them. It has a great model, but it's also pretty complex to run. Even with the managed control plane, there's a lot of work you have to do. You have to start virtual machines. You have to manage the lifecycle of virtual machines. You have to do many, many things to actually keep that cluster running, things that we could probably do for you and that customers have asked us to do for them. And so for us, a managed Kubernetes control plane was just the beginning. Phase 2 is removing the undifferentiated heavy lifting that you have to do to actually run all the compute resources for your cluster. So we're doing that in 2 ways. The first way, we actually just announced a few weeks ago at KubeCon. This is EKS Managed Node Groups. And what Managed Node Groups does is it's automation that makes it easy to start virtual machines for your cluster and your account. Managed Node Groups actually kind of is like in between the lines, because while EKS starts all those virtual machines, it starts them in your account. So it's just a little bit of automation tooling. You still have to scale instances. You have to know about the instances. You have to think about the instances a little bit less than you used to, but you still have a little bit of work to do. And so what we're really excited to announce this week is AWS Fargate support for EKS. And what this means is that you can run your Kubernetes pods directly on Fargate, which is our serverless compute engine for containers on AWS. So why did we make Fargate? Like, what's the point of this, right? We designed Fargate so that you make it easy to build and run your applications on the cloud, and we want to give you smart building blocks for compute. We want to give you the option to be able to come to Kubernetes, come with the pods that you already have, and just run those on Fargate without having to worry about complex configuration or managing multiple layers of infrastructure. So Fargate gives you everything you need to run highly available, fast-scaling Kubernetes applications on AWS. We built this integration really carefully so that you can bring existing pods, and it will work in a way that you've already been using the Kubernetes API, and it will just work. You don't need to change how you've defined your applications to have them run on Fargate. You actually just tell EKS which pods you want to run, and they're going to start on Fargate. The pods launch quickly. They run across multiple AZs. Every pod that you run is right-sized. So it gets the right amount of compute, vCPU, and memory resources that you ask for in the Kubernetes API. And these things are ephemeral. So the pod launches, you get the compute that you need. If you need to run more pods, you just start running more pods, and we provision the micro VM environment that you need to run those pods on demand for you. It's also really well integrated with AWS. You get native integrations for networking, security, and other things. So what really matters for Fargate is that it's a little bit confusing sometimes, because previously Fargate only worked for Amazon ECS. So you may be familiar with it in the ECS context, right? But we see Fargate actually as not an ECS construct, but as a general purpose compute engine for running containers on AWS. And we've built and will continue to evolve Fargate and its integration so that the only differences in Fargate are driven by the particular orchestrator that you're using. If you're using Kubernetes, then you're going to use Kubernetes principles and Kubernetes APIs. If you're using Amazon ECS, then you're going to use Amazon ECS principles and the AWS APIs. So those should be the primary differences between Fargate, whether you're using EKS or ECS. Now, of course, some orchestrators like ECS may come out with a feature before we have that feature for EKS, or vice versa. But in general, we're going to track towards Fargate being a general purpose compute platform that behaves the same whether you're using ECS or EKS. So now my friend and colleague Massimo is going to take you on a quick tour of EKS and Fargate, show you exactly how Fargate works with the Kubernetes cluster, and discuss some of the important things that you need to know to get started.
Thank you, Nate. This Red Bull did work out. Can I have some? Can I have some?
Go for it, yeah. Got to keep going.
This was not prepared, but I saw the energy, so I thought, okay, let's have it. So thanks for coming. As Nate said, my name is Massimo Refere. I'm a developer advocate in the container service team. So in the next few slides, I'm going to show you how this works from an architectural perspective. Before we go and talk about the actual integration, and most of the session is going to focus on the integration itself, so I'm not going to spend too much time talking about Fargate. I'm not going to spend too much time talking about EKS itself. I'm going to talk more about how these two come together. But I wanted to level set the audience because maybe you have not used Fargate so far with the ECS control plane, because that was the only control plane that was available until Tuesday this week. The way that Fargates work is like this. So there is stuff that we manage for you. In this case, is the control plane. This slide would be like orchestrator agnostic. Like it is the very same thing for both ECS and EKS. I'm going to use the EKS language just for the sake of the session that we're in. So when a user, a Kubernetes user, asks the control plane to deploy a container on EC2, what happens is that that control plane, EKS in this case, is going to take that pod, the Kubernetes pod, and instantiate it on the EC2 instance that is running in your account, right? So there is a AWS manager account and your account. In your account, there is your VPC, there are your EC2 instances, and that pod is going to land on those EC2 instances. This is what you have been using so far on EKS. What we have introduced this week is another model, which, oh, by the way, I forgot to say that when you are in this situation, obviously you're going to have to manage those EC2 instances. As Nate was alluding to, manage node groups alleviate that problem a little bit, meaning that we take on some of the management stuff, like updating all the kubelet, the Kubernetes agent, like the kubelet and other things, but those instances are in your account, so you need to take care about how you're going to scale them, scale out, scale in, draining of the nodes and stuff like that. The way that works with Fargate is very different, meaning that when you are saying, I want to deploy my pod or my container on Fargate, what happens is that that pod that you're going to deploy doesn't go into your account. It goes on a fleet of micro VMs or VMs that exist within our account, and particularly in the Fargate fleet. So that pod comes up in our own account and gets connected to your VPC. So the end state, the pod running in your VPC as a first-class citizen, is the very same compared to what we have seen before, but where that pod runs and where those CPU and memory resources are very different, and where those are is very different. Obviously, the advantage here is that there are no nodes, right? So there is no EC2 instance whatsoever, because that is where the pod is running, on the Fargate fleet that you don't get to see. So as we started to socialize this with customers, some of them were confused about the difference between managed nodes and Fargate. Nate alluded to some of the things. We wanted to create this small table just to point out what the differences are. So if you think about the unit of work and the unit of charge, for Fargate, they are always the pod, right? Since there is no EC2 instances, the unit of work, I mean, the object that you have to deal with is the pod. The object that you get charged for is the pod. For managed nodes or unmanaged nodes or node groups, you have two units of work, right? You have to take care of the pods that you need to deploy, and then you have to take care of those EC2 instances. The unit of charge is also very different, and it's very core to the Fargate value proposition, whereas we charge for the pod with Fargate, we charge for the EC2 instance in the traditional data plane model. Other things that Nate was alluding to is the management of those instances, right? So for Fargate, in terms of host lifecycle, which host AMI or AMI?
AMI. Oh,
yeah.
well, that's a battle for the ages.
Yeah. So, AMI?
AMI.
AMI? I'm going to say AMI.
Okay.
So the host AMI, they don't even exist in the Fargate space, right? Because you're never going to see, never going to pick a AMI to deploy your pod. Whereas for managed worker nodes or unmanaged worker nodes, there is a very a various degree of flexibility that you have. I'm not going to discuss too much here, but there are EC2 instances that are running in your account, and you need to make decisions there. The last point and the last difference is that typically with an EC2 deployment, you have a one-to-many deployment. Like you have one host that supports many pods. With Fargate, we only deploy one pod per micro VM or VM from the Fargate fleet, right? There is a one-to-one mapping between the VM that we source from the Fargate fleet and the pod that you are deploying. So to recap this is what you have been using up until today, right? So your Amazon EKS managed control plane that deploys pods to EC2 instances that are in your account. This could be managed or unmanaged, but they are running in your account, and you have to, manage auto-scaling group and, the draining and all of these things. With Fargate, which is what we're introducing this week, you get the chance from the very same cluster to deploy to both a traditional EC2 data plane as well as what we call a serverless container data plane. Okay, that is what we are announcing this week. The model that we support is both what you saw before, like EC2 only. We support this mixed mode where you can deploy from the very same cluster, you can deploy to Fargate or EC2, and we also support Fargate only. So you can have a Fargate only cluster where you have basically no EC2 instances whatsoever because you don't get to see the EC2 instance for the managed control plane, and you don't get to see the EC2 instances for the Fargate fleet. Having that said, before we get a little bit deeper into how these work, we thought that it would be better to show you first how these actually work in reality. Okay? So the setup that I'm going to show you is very basic. So I have created an EKS cluster that supports Fargate, and we will get into some of these details about what that means. And this cluster is pretty empty, right? I pretty much shut down everything just to show you the mechanic of how this integration works. This is not representative of a production cluster because, for example, it doesn't have any pod running, right? So I just shut down everything. Obviously, if I do get nodes, for example, what would you expect to see? Nothing, right? There is no nodes in this cluster. So if I go to the EC2 console and I look at what I have, I only have this Cloud9 environment, which is the client that I'm using here to show this stuff, right? So there is no other EC2 instance in this account. So what I'm going to do now here is I'm going to deploy a pod in the default namespace. Okay? What I'm going to do next is I'm going to show you the namespaces that I have here. And I'm going to create a new namespace. Let's call it demo or whatever. And what I'm going to do is I want to deploy the very same YAML file, the very same pod in the demo namespace. Okay? So I have deployed the very same pod from the very same YAML in two different namespaces. This pod doesn't do fireworks. It's just an NGINX, right? It's a deployment with one replica of an NGINX image. It's just for the sake of the discussion. This is not a fancy demo like the one that we showed with, that Claire Liguori showed today. It's just for you to understand what's going on. So let's see what happened. If I do get pods, something interesting happened here. So I do have these two deployments, or two pods that has been deployed, or actually just one has been deployed, right? So the one in the default namespace has been deployed. As you can see, it's running. The other one is pending. right? And we can stay here forever, and it will not come up. And there is a reason for that, that we will see in a second. So now that I have that pod up and running, I can do pretty much everything that I want to do with it. Like I could, for example, exec into this pod. Right? It's a regular Kubernetes pod. The other interesting thing that I could do is if I do, again, get nodes, I see a node that came up. That is the node that we sourced from the Fargate fleet and we used to run that pod. So that pod will have an IP in your VPC, but it's not running inside your account. And the proof of this is that if I go here and I refresh here, there is nothing, right? There is no EC2 instance. Obviously, we are running this somewhere, but you don't get to see where this is running, right? So there is no auto-scaling, draining, whatever. Every time you start the pod, if that pod starts, and we will get into why the other pod didn't start, but if that pod starts on Fargate, we're going to source a VM on the fly. We're going to run that pod. If you shut down the pod, we will put that VM or micro VM back into the pool. So let's try to investigate why the other pod didn't come up. So this is the EKS cluster that I created called Fargate. This is a regular EKS cluster. The one thing that you see here is node groups. This is what we announced a couple of weeks ago, the managed node groups. Like I could go here and say, I want a node group, like 5 VMs, 5 EC2 instances, and it will deploy those into my account. As you can see, I don't have anything here. The thing that we announced this week is these Fargate profiles, right? So the difference between last week and this week in the EKS console is that there is now this entry called Fargate profile. I have created a Fargate profile already that is called default namespace, and this should give you a hint, right? So basically what happened here, other than having to set pod execution roles and networks that we will explore in a second, we have this notion of the pod selectors. So the pod selector is what allows me to say everything that comes in that matches this selection will go to Fargate. If it doesn't match it, it will go to the standard Kubernetes scheduler, okay? So in this case, as you can imagine, I have a single Fargate profile that has a single pod selector, which is namespace equal default, and I don't have any labels, because I can also set the labels, right? Not just namespaces. So I can say, but we will see this more during the presentation. I can say everything that goes into default and has a particular label go to Fargate, okay? Okay. So let's go back to the slide here. So how does this work? How does all this work in the back? So as a recap, right? So when you think about EKS, Amazon EKS, there are two things, right? There are the EKS API, which allows you to do things like create a cluster, update the cluster, delete the cluster, and stuff like that. And then there are obviously the Kubernetes API, which is what your user is actually using, right? To do kubectl apply, which is everything that we have done so far. So what we have done is we have introduced an additional API to the Amazon EKS API, which is this API that lifecycle this Fargate profile, right? So you can create, delete Fargate profiles with this new EKS API. And this is a representation of that profile, right? This is not intended for you to read. I just wanted to bring this up because I want to discuss a couple of very important things and the reason for which we introduced the profile and what the Fargate profile role is. So this could be a representation of the Fargate profile that I show you very briefly in the demo. The reason for which we introduced the Fargate profile are two main reasons. So the first one is what I was discussing about the pod selector, right? So we need to have a mechanism to say, if I deploy a pod, how do I know where it should go, right? Should it go to Fargate or should it go to the standard data plane, EC2 data plane? So the pod selector section is responsible for matching that, right? So that is where you would put like, the namespace, the labels, and everything. So this is the first reason for which we needed to introduce this notion of the Fargate profiles. There are another reason for which we needed to introduce this notion of the Fargate profile, which is everything that runs within AWS needs to have a context, right? An AWS context that doesn't necessarily exist in Kubernetes, right? For example, the networks that I'm going to connect this pod to, right? The pod execution role that I was mentioning very briefly during the demo. That is the pod execution role that gets that gets associated to the kubelet, for example, so that the kubelet has rights to go and pull from ECR, for example. Okay? So those are the two reasons for which we had to introduce these Fargate profiles. For having a mean to have this match between what I'm doing on the Kubernetes side and to determine whether it needs to go to Fargate or EC2, and to give that pod a context in the context of AWS. So let's go through an example. Hopefully this diagram will clarify some of the things. So this is a traditional setup, from this week on, of an EKS cluster that has a couple of different data planes configured, Fargate and EC2 instances. So this is different from the setup that I showed you in the demo. There are worker nodes in this example that I'm showing here, but there is also a Fargate profile that will enable the deployment of a pod to Fargate if there is a match, okay? So the other thing that you can see on this slide is that we have extended the Kubernetes cluster using the standard Kubernetes mechanism like the webhooks, the dynamic webhooks to allow this, to intercept this pod and mutate them on the fly. And the way that this works is like this. So imagine that you, the user, comes in and deploy a pod in the prod namespace with a specific label, which is stack equal blue. Okay? That is how you're going to deploy that pod. There are validating and mutating webhooks running on the cluster that will take that request, and they will send it to EKS. And they will ask, is there a match for these namespace and labels that I see coming in? If the webhooks determine that there is a match, and in this case there is a match, because there is a Fargate profile that say, if there is something coming in from the prod namespace, and there is that label, stack equal blue, send it to Fargate. So what happens in this case is that those webhooks, there is a mutating webhooks that mutate on the fly that pod, and it will insert the Fargate profile and the scheduler, a custom scheduler that we built on top of Kubernetes, and that pod will be sent to the Fargate scheduler to be scheduled on Fargate. Again, this is not hacking Kubernetes. These are the traditional way. This is the traditional way that you would use to extend the capabilities of a vanilla Kubernetes cluster. A different example is if I'm coming in and I want to deploy a pod in the test namespace, different pod, different namespace, same thing. The webhooks are going to ask EKS through those API, is there a match for this? Or can you give me the list of Fargate profiles that exist so that I can determine if there is a match or not? There isn't a match in this case because the only Fargate profile that I have says namespace prod and label stack equal blue. So the webhooks will say, no, there isn't any match here, so I'll just send it to the standard Kubernetes scheduler. What is the standard Kubernetes scheduler doing here? It will just send it to the EC2 instances over here. that is the reason for which that pod that I deployed in the demo namespace was pending, because it was sent to the standard Kubernetes out-of-the-box scheduler. There wasn't any EC2 instance, so it would stay pending forever. I could have done two things to bring that pod up. I could have deployed a node group, in which case it would see instances and it would schedule pod on those instances. Or the other thing that I could have done is I could have created a new Fargate profile that said namespace equal demo, and when the Fargate profile was created, that would have been scheduled on Fargate on the fly. Okay? That is how this works. Which means that you can do very interesting things with this. I may not be as excited as Nate to say this is more exciting than going on the strip, but I think that it's kind of interesting. So do you need to modify this, the spec of your pod that you're actually using in production to deploy to Fargate? And the answer is no, you don't have to do that. You can create this matching on the Fargate profile side of things so that you can determine without changing that pod spec whether that pod needs to go one way or the other, right? So the process here is you can run a pod on standard worker nodes. You can create a Fargate profile that happens to match the selector of that pod in namespace and labels. You can kill that pod, and that pod will start on Fargate without you having to do anything. So a visual representation of this is this. So imagine that you have a cluster like this, similar to the previous one, but there isn't any Fargate profile defined on this cluster. So I'm coming in, and I'm trying to deploy a pod in the default namespace. Same process. It's going to ask, give me the list of Fargate profile that you have, and EKS is going to say, oh, I don't have anything here. Okay, let's deploy it on EC2 then. Then what I'm going to do next, as an EKS admin, I'm going to create a Fargate profile that says namespace equal default. If I come in again, either I kill that pod or I come in again with the same pod spec, as you can see on the top right-hand side, and I deploy that pod, it goes through, give me the list of Fargate profile that you have. It will give you that list, and the mutating pod will say, oh, there is a match here. So let me change that pod spec on the fly. Let me mutate that pod spec on the fly to insert the Fargate profile name and the custom scheduler, send it to the custom scheduler, send it to Fargate. Okay? So that is how the mechanic works. The first thing, one of the most important things that we need to cover here is how do we size that pod? And here we need some more Red Bull.
I think what's really cool about this is that when we launch that pod, we're going to give you on demand the resources that that pod needs to run. And we're going to size based on the resources that pod needs to run. So there's a little bit of mechanics that go on here. How do we figure that out, right? Yeah,
exactly. Because with when you have a bunch of EC2 instances, that is the size of the environment that you have. So the Kubernetes scheduler will know, what to do, right? I can schedule because I have resources, or I cannot schedule because there are no enough resources, in which case, if there is cluster autoscaler, I can scale up and blah, blah, okay? But since there isn't any EC2 instance, what do we do, right? So we need to bear with me, because this is going to be, quite sophisticated, because I want to cover many use cases, right? So if you're running just one container in a pod, it's going to be easier to determine what that size is. But with more sophisticated setup, you need to understand how we do things so that you get a better understanding of how this works. So the first thing first is everything that you're going to see here has two dimensions, CPU and memory, right? Everything that I'm going to discuss is for CPU and memory. Same process for those two CPU subsystems. Second thing is, as you know, there are two types of containers that can run in a pod. There are init containers, and there are the standard containers, right? So they could be sidecars or your application containers or everything. As you know, init containers has a characteristic, which is they start, they stop, they start, they stop because they prepare the environment for the long-running containers to run. Okay? That is how it works. So let's imagine that we have an init container. Okay? That init container will have request and limits, right? And this could be explicitly set within the pod spec, or they could be needed by, from the namespace. But typically, they will have request and limit. Request is, this is how much of CPU and memory I need to be able to run. Limit is, if I need more capacity other than what I'm requesting, I can use it up to that limit. Okay, so if you land on a super powerful EC2 instance, if you set the limit to 2 GB of memory, for example, it's not going to use more than 2 GB of memory. Okay? So this is the first init containers. So these init containers come in, goes, and then maybe there is another init containers that start and stop, and then there are maybe a couple of long-running containers. This could be 1, it could be 3, it could be whatever, right? Let's say that there are 2. So what do we do? So the first thing is that we discard the limits. We only take into account the request, okay? How much a container needs to be able to run. Then, since the long-running containers are long-running, what we do is we add them, okay? So we add them together. What happens next is that we pick the highest number between the individual init containers and the sum of the long-running containers, right? So in this case, that is the number, and we do this process for CPU and memory that we use to configure CPU and memory. Let's go through another example. Imagine that you have this setup. Again, a couple of init containers and a couple of long-running containers. So this example may not be very real life because there is an init containers that has requests that are greater, a single init containers, than the sum of the long-running containers. Maybe it's not very real life, but if we see something like this, we pick that because it's the highest of all of those numbers. That's kind of the logic that we use to size the pods. So imagine that you are in a more real-life environment like this one. Maybe a couple of other init containers and 4 long-running containers, and that is the number that we pick, right? So how do we translate that number into a Fargate task size that we document? So for those of you that do not know Fargate, Fargate allows you to pick a particular size, right? So you can pick like 1 vCPU and 4 GB of memory, or 1 vCPU and 8 GB of memory, or stuff like that, right? Combinations between CPU and memory. So we use that number, actually 2 numbers, 1 for CPU and 1 for memory, and we go through this table to create this combination. We do one additional thing before doing the magic, which is we add 256 megabytes of memory to that sum for the Kubernetes component, right? Because within that pod or within that environment, we also run the kubelet and everything, which is taking up some memory that we need to guarantee for that kubelet to be able to run in that node. When we have those 2 numbers, then what we do is we go through this table here and we pick the closest config, round it up. So imagine that out of this configuration, the output of the memory number is 1.8 GB. We pick 2 GB in the size, okay? So that's kind of the logic that we use to size the pod. Let's go through some additional slides on the networking and security architectures and storage before passing the ball back to Nate. So this is what we have been running up until today, right? So you have 1 or more instances in your account. Each of them has 1 or more ENIs, or actually minimum 2 ENIs, 1 for the Kubernetes components and 1 for the pods. And then we give those pods secondary IP addresses out of these ENI for them to have a routable IP address, which is kind of how Kubernetes works. Flip this into the Fargate model, this is what happens. So every pod is going to run in its own environment, in its own VM or micro VM, when we are going to use Fargate in this case. Okay? So that is kind of the setup. The thing to keep in mind is that as of today, with the launch here, even though each pod has a dedicated ENI because it's running on a dedicated VM from the Fargate fleet, we are going to assign a single security group to those ENI. So the model now allows us to be a little bit more flexible in the future, to be able to say this pod has a particular security group and this pod has a particular security group. So we could differentiate potentially. But at launch, we decided not to do this to make things a little bit easier for the user, okay, for now. So every pod that you deploy in that cluster is going to have a single security group, pretty much like what was, how it was happening with the traditional worker nodes. Good. Some load balancers consideration. So the ALB ingress works as it usually does. Right? So for those of you that are using the ALB ingress, it will just work. Make sure that you are going to use the latest version because we had to do some minor changes to make it work with this new model, but it just works as it used to do. NLB support is coming soon. Okay, so it doesn't work today, but it's coming soon. Nate told me to say it's coming soon.
Soon.
Okay. CLB, it won't work because CLB, or the classic load balancer, assumes that it needs to connect to instances to be able to run. And since there are no instances, because they won't show up in your account, it cannot work. Right? So the only two options that we're going to have is ALB and NLB for the Fargate model. Okay? For the traditional EC2, it's whatever you have been using today.
And those are managed load balancers, right? So if you're using things like Nginx or Istio Envoy for ingress, those work as well. So ALB uses ingress, and anything that uses ingress will work on this.
So storage options with EKS for Fargate. This is an easy slide because Fargate doesn't provide, as of today, as a whole, and this is regardless of EKS or ECS, doesn't provide a way to run persistent pods. Right? So everything with Fargate is ephemeral. There is storage that you get within that instance that you could use temporarily while the pod is running, and you can use that storage, ephemeral storage, to share capacity between those containers. But once you shut down the pod, that storage is gone. It's ephemeral. The instance will be put back into the pool, and everything will be discarded. Okay? The other thing is that obviously lots of customers are asking for this, right? So we are, trying to see what the art of the possible is, because, we heard that many customers want to run persistent workloads on Fargate, and we're trying to explore that. Last slide before I pass the ball back to Nate, EKS CTL support. So as you know, EKS CTL is a tool that we built together with Weave, and it's one of the primary tools that we suggest customers to use to stand up EKS clusters, right? It removes a lot of the undifferentiated heavy lifting that you would have to do to set up an EKS cluster. So as of yesterday, 11 a.m., we have a new version of EKS CTL that supports Fargate, right? So you could use EKS CTL to deploy a cluster that supports Fargate. What does support Fargate mean in this case? It only means that EKS CTL will deploy a cluster just like it normally does, and it will create some default profile for you, because otherwise you would need to create the cluster and go and create your Fargate profile. EKS CTL will do that for you. With EKS CTL, you can create a Fargate-only cluster or a mixed cluster. All right? You could create a cluster with both worker nodes, managed node groups, as well as Fargate support, meaning that it will create those default Fargate profiles. And this is what I was saying, that EKS CTL takes on some of this undifferentiated heavy lifting. The easiest way to start with EKS for Fargate is by launching this command. If you download EKS CTL, and you do EKS CTL create cluster -- Fargate, it will go and create a cluster with no managed nodes, no worker node, no EC2 instances, and with those default Fargate profiles that it will create for you. Obviously, you can come in and delete them or create others, but this is the easiest way to get started. With that being said, I'm going to pass the ball back to Nate.
Awesome. Thank you. Thanks, Massimo.
Sure.
I hope that by this point in the presentation, everybody is incredibly bored.
Thank you.
You're welcome. I actually think another way to think about undifferentiated heavy lifting, and that really, it's a tongue twister of a phrase, it's how awesomely boring can we make this stuff, right? This should be incredibly boring to use and run. It should just work. That's our goal, is to make your infrastructure incredibly boring on AWS, and I'm actually really excited about that. It's a pretty good thing. So a few UX changes. I mean, in the incredibly boring camp, things you don't have to do. You don't have to manage worker nodes, pay for unused capacity, use the cluster autoscaler. This may make your life a little bit less exciting when you don't have to worry about configuring multi-AZ Kubernetes cluster autoscaler in the moment that you are worried about your application scaling and, oh my gosh, don't let us have an outage. Boring. Like I said, you get to sleep in and not have that 2 a.m. alarm go off. Things you get out of the box. VM isolation at the pod level. Pod level billing is a really cool outcome from Fargate. There's a very challenging unsolved problem in Kubernetes, which is I have a lot of different applications and they're all sharing resources. How do I figure out what's using what and how much should I charge for it? And that was on a C5 XL and that's on an M5 large, and oh, that one was Spot and that one's reserved instance and that one's using savings plan. Oh my God, now our accountants aren't bored. So we're gonna actually give you, on your detailed bill in AWS, every pod that runs, you get the cluster, the account, the region, the namespace, the service, the pod ID on a detailed line item bill. So you can take that report, you can throw it through some sort of a wizard, Tableau, all sorts of other things, and you can actually see the exact cost, vCPU and memory, that you paid to run that pod. So this makes it really easy to do chargeback scenarios for multi-tenant clusters. Things you can't do. I'm gonna actually pick a few things out of here. So daemon sets and privileged containers. These are just things that don't work with Fargate. Fargate is a micro VM per pod. So you could, technically, we might be able to allow you to run daemon sets and you would just get an infinite number of pods. And they would actually have no relation to other pods. And you just have a million log drivers running on your cluster and it wouldn't really do you much good. These pods are isolated in their own micro VMs. Same with privileged containers. Fargate is serverless. There's no host. There is a host deep down in there that we're running for you and we're managing for you, but privileged containers are not something that work. Massimo mentioned some things that are limitations that we are going to be removing, NLB being one of them, and then also stateful workloads. Bringing support for EFS to Fargate is a priority for us. So there's also a few limits that you should be aware of as you start using Fargate. There's a default limit of a global 100 pods and tasks per account that you can have that raised. And due to kind of how this works, there's I actually think a limit's the wrong word here. The Kubernetes community tests up to 5,000 nodes in a cluster, and that's the well-tested standard upstream testing. So 5,000 pods will work really, really well. Once you get beyond that, the way that you're running your cluster kind of starts to change, and there's a bunch of different things that you can do more of. You can have a lot of namespaces on a Kubernetes cluster, or you can have a lot of nodes on a Kubernetes cluster, or you can have pods that are recycling a lot on a Kubernetes cluster. If you want to max all of those things out, things start to not go so well, but you can typically stretch a little bit higher or a little bit farther on one of these dimensions.
Yeah, the other thing that you may want to mention is the fact that we want to work with the community, not just to raise the number, but to make Kubernetes more like serverless.
That's right.
By design, right?
There's running threads on Twitter over the last few days about this, actually.
Yes.
And, working with the community, and we're not the only cloud provider, right, doing a serverless compute like this. And so working with the community to have a serverless compute model for Kubernetes is something we're actually super excited to be working on. Interesting outputs from this solution, like some interesting conclusions that happen is scalability. So if you are running a really underutilized cluster, let's say that you have a lot of empty VMs sitting around and you need to start pods. Those pods are going to start pretty darn quickly because all the compute resources already exist. They're provisioned. They're live. You're paying for them. And those pods are going to start super quickly. If you have a situation like that, Fargate's actually going to be a little bit slower to start a pod than starting a pod on an empty VM. But that's actually, if you're trying to run in a cost-optimized scenario, in a scenario where you're actually trying to get a little bit better than like 25% utilization out of the money that you're paying AWS Cloud every single month, then you're probably going to want to run less virtual machines, and you're going to want to pack them a little tighter, meaning that when you scale, you actually have to start new virtual machines. And in those scenarios where you're scaling out, in order to run more pods, you have to actually start virtual machines first. Fargate's going to be significantly faster, usually about like half the time or less to start a new pod. So there's two ways to look at that, and it's an interesting consideration when you think about what you're running and how you're scaling. So pricing for EKS and Fargate is unchanged. This is super important for us. Fargate is a unified compute layer, and no matter which orchestrator you come at Fargate with, you're going to pay the same Fargate price for vCPU and memory. EKS cluster pricing also remains unchanged. An EKS cluster is just 20 cents per hour. So EKS on Fargate is generally available for all AWS customers with new EKS clusters starting on Tuesday. You can get this in a few ways. You can create a new cluster using EKS Cuddle version 0.11. You can go to the console. You can use the AWS API, CLI, Terraform. There's actually, we didn't talk about this before, but there is a Terraform provider for Fargate profiles now. Really excited to see Terraform come out and launch that right away. You can also update an existing 113 cluster to version 114, or if you want to go from 112 to 113 to 114, you can do that too. What's not quite there yet is using 114 clusters that were created before this week with Fargate. We're going to be updating all of those clusters automatically over the next few weeks. So if you are in that situation, hold tight. We're gonna be doing that update automatically. And you can use EKS with Fargate in 4 global regions. We'll be expanding to all global regions within the next year, but today it's Virginia, Ohio, Dublin, and Tokyo are the 4 AWS regions where this is available. And with that, really want to thank everybody for coming. Really appreciate your time here. I think we just have a few minutes left for questions if anybody has any about this integration. Thank you.
Thank you.